Go ahead and get out your formula sheet, if you will. Everybody, formula sheet that I gave you yesterday. We're going to add these last two equations to it. And then you might want to write down a couple more notes, which we'll talk about in 2 seconds. It is. There we go. So what I'd like you to do is on that formula sheet, write this. This is compound interest right here on your formula sheet. Find compound interest. Compound interest. Kind of towards the middle. It's right after the one we skipped, which says changing annual depreciation to monthly. We're going to skip that one. I don't really want it. For N, you're going to put number of times compounded. Number of times compounded. And then T must be time in years. Okay? But you can kind of see this right here to the right. N is the number of times it's compounded per year, and then T is time in years. So write that formula down. And let's talk about above this on the note sheet. Keep your formula sheet out for just a second.
Did you go over that?
No, this is a brand new formula.
No, I'm talking about the formula.
Probably. Yeah, probably did. Yeah, yeah, if you don't have that formula sheet filled in, it's all the formulas so far that we did on the sheet before. And I would put mine up, but it's on my iPad. And like an idiot, I left that at home. So you might want to get that from somebody close to you who may have it, okay? Okay, so everybody with me?
Mine doesn't have the A equals.
What now?
Mine doesn't have the A equals. Is that it's supposed to look just like that?
I think you should get ahead.
No, right here, compound interest. This is where you're putting that.
Is it right here?
Yeah,
so
you got it.
P equals.
Really?
Yeah.
Oh, that's not on there.
You got this?
Which one?
You don't see? Like, that's what you're telling me to write.
Yeah,
right.
No, just, you probably put N as the number of times. You already know what A, P, and R are. Because we have those at the top. Alright, so let me explain real quick. The only thing that's new with all this stuff over here, look, y'all got A, P, and R at the top. Now, I know I put A was accumulation, which is the same concept. It's the money that's accumulated. The only thing that's new here is that N. N is the number of times it's compounded, so you can fill that in that spot. And then T, of course, is time in years, which it was in a couple of other formulas too. So all that other stuff up top, same concept, okay? You're still going to have an initial amount, P. You're still going to have some rate that's given to you. You're still going to have to change it to the decimal, right? But this is the new thing. Now, to set this up, here's what I like to kind of do. You guys remember annual appreciation we talked about yesterday. It's when something is appreciated just once a year, right? So I want to show you one thing about compound interest. See, this very first concept up here is, what if it said that it's compounded annually? Well, if it's compounded annually, it means it would be done one time a year. Okay? Now go back down to this formula. Let me show you something. If I plug a 1 right here for N, what is R divided by 1?
Some of us have pictures now. We got a notification.
Science and Unity Club?
Yes.
Okay. If you're in those clubs, which club are you in?
You're in Unity Club?
Unity.
I'm gonna jot those down. Check.
I didn't know you were in Unity Club.
Hey, you should get a picture of somebody's sheet.
I bet Caitlin. Okay, Josh.
She already knows pastors back here.
He's out, someone get those good.
Okay. So let me get back to this. Okay, y'all ready? If I took R and divided it by 1, what does that equal? R. Look up here. If I plugged 1 into in here and did 1 times t, what does that equal? T. So let me explain something. If this were compounded annually, wouldn't this just say p times 1 plus r raised to the t? Isn't that the exact formula we talked about yesterday?
Yes.
Okay, so here's the point. If this thing is compounded annually, it's just like appreciation. So the purpose of this equation is not necessarily for the annual appreciation, it's for all the other ones. You see, sometimes money can be compounded more often than once a year. In fact, you'd love it to. The more it's compounded, the better off. You're going to get interest multiple times. So you got to be familiar with the compound interest formula, specifically with what the number of times it's compounded annually is. So here are the terms. What if it says that it's compounded semi-annually? How many times would it happen if it were compounded semi-annually? It'd be twice. It'd be twice. What if it said that it's compounded quarterly? That would be 4 times per year. 4 times per year. Quarterly. How about monthly? 12. And I didn't realize it. Maybe a lot of us don't know. How many weeks do we have a year?
52.
It's 52. I've had a couple people say 48 so far today. And that's okay if you didn't know that. But there's 52. If it says weekly, you're going to put 52. What if it says daily? So when it tells us that it's compounded in one of these ways, we're going to go to our equation and we're going to replace in both of those 2 locations with that value. Okay? Everything else is just like we have already talked about. Now, let me show you something. And this is the last formula that you'll need to write on your formula sheet. So if something was compounded 100%, okay, yearly, this is what happens if you go semi-annually. This is what would happen if you go quarterly, monthly, weekly, daily, hourly, every minute, every second. So as we go and compound more and more often, as we get closer and closer to constantly compounding whatever that value is that we're doing, do you notice what number this was moving closer and closer towards? Not 3. 2.71828. Remember that number? That is E. That is my Euler number. That number that I told you is seen so much in nature, in real world application problems, that they decided to just give it its own variable and to make it a mathematical constant. So when something was possibly constantly compounded, it has a specific formula. It's called continuous compound, and that formula is P times E to the RT. P-E to the RT. PERT, if you want to remember it that way, or like I rapped the other day, P-E to the RT. Okay? So when something is being compounded continuously, that's the equation that we use. And you know all the values of it. P is your initial amount, right? E is a mathematical constant. You can find that button in your calculator in 2 places. And then, of course, R is the same rate that we've been talking about, and T is the number it's the time in years. So here we go. Let's look at some examples of this. And I think you guys will really understand what we're doing today and notice how it's different than what we did yesterday. So look at example number 1 for me. It says Wendy deposits $550 into a savings account. Does that look any different than yesterday's questions? No. But here's what it says here. Next, it says the account pays an interest rate of 4.5%, what? Compounded quarterly. That tells me 2 things. 1, it tells me what formula to use. What formula do I have to use for this problem? But where do you put quarterly into? The compound interest formula. So when it tells me it's compounded quarterly, that tells me immediately I'm using compound interest. And the second thing it tells me is that I'm putting what for n? I'm putting what for the number of times it's compounded every year?
2.4.
For n, the number of times it's compounded?
4.
4. Why? Because it used what word? Quarterly. Okay? Quarterly. So here we go. Here's our equation. What's that? What'd you say? No, you're not. So it says write a function that gives the amount of money in dollars, W of T, in Wendy's account, T years after the initial deposit. What's that initial deposit, guys? What's P? 550 times 1 plus, what's my rate? Isn't it 4.5%? Not 0.045. Remember, move your decimal 2 to the left. That's divided by n. What's n? You already said it. It's quarterly. So n is 4. So n is 4 to the t power. 4t power. Look, 550 is p. 1 plus r over n raised to the n times t power. That's my equation. Now, generally, just like with our homework, if you saw this on a test, will they leave it like that? No. If you see this on a test, the equation will be cleaned up on the inside of that parenthesis. So inside that parenthesis, here's what they're going to do. They're going to do 1 plus alpha y equals number 1. They're going to put 0.045 divided by 4, and they're going to write 550 times 1.01125 raised to the 4t power. Okay? All right. Now, how do I finish this thing off? What's the question asked me? Find how much is in her account when? In 10 years. So you're going to go 550 times 1.01125 raised to the 4 times 10 power. So again, with our calculator, 550 times 1.01125 raised to the 4 times 10 power, and we get approximately what? All right, so is compound interest just a lot harder than what we did yesterday? It's not, okay? It's not a lot harder. Now, it does have that n value, so we have to change a little bit of what we did yesterday, but it's really not that hard. All right, example 2. A couple makes an investment of $1,800 into an account that does what? It earns 8% interest. Compounded monthly. That tells me 2 things. 1, I'm definitely using what formula? Compound interest. And 2, it tells me that n is 12. Again, how do we know that? Monthly. Monthly. There's 12 months in a year. So here's my answer. Does it ask me to write an equation? No, it just tells me to find how much she'll make in how many years. So here we go. She will make 1,800 times 1 plus, what's R if it's 8%? What's R if it's 8%?
0.08.
0.08, right? We moved it 2 to the left, or divided 8 by 100. Over n, what's n? 12 raised to the n, 12 times t, 15 power. Look, I just got everything straight from my formula and my word problem. Now let's just type it all in. 1,800, open parentheses, 1 plus alpha y equals number 1. I did plus plus. So we got 0.08 up top. We got 12 in the bottom. We close that parenthesis and we raise it to the 12 times 15 power. Does everybody see that? So all I have to do is push equals, and my answer is she will have $5,952.46. 46 cents. Okay? What do you think? It's not too bad, right? Okay, let's look at the problem on the back, and then we'll look at little more challenging problems at the bottom. Okay, first, Sarah deposits $2,000. What's that? What's that? What's that stand for? P. And she invests it into an account that pays what?
2.7% interest.
It's compounded how?
Compounded
Continuously. So that tells me I'm using what formula? I'm using what formula? P, compounded continuously. Remember what it is? P, E to the RT. So let's solve this thing. First, it says to write an equation. So S of T, it says, equals, what'd y'all say P is? What's E? Somebody say it's a mathematical constant. Absolutely. You just put E. It's a number, right? 2.71828. Now, it's raised to the R. What's R? Very good. 2.7% is changed to 0.027. And then, of course, T. It wants the equation first. There's my equation. 2,000 times E raised to the 0.027 T. So what do I do to solve this thing all the way out? It says find the amount after how many years? 30 years. So 2,000 E to the 0.027 times 30. So grab your calculator. 2,000. Remember, where do you find E? A couple of places, right? Second divide or second LN. So second divide is what I use most of the time. Raised to the 0.027 times 30. Questions with that? So we push equals, and it's going to be how much? $4,495.82. $4,495.82.
Teachers, at this time, the following homeroom students need to report to the theater. Miss Bailey Brown, Mr. Rutledge, Miss Smith.
Is anybody in here in vocal
Miss
height
Stewart,
or
Mr. Walker,
unity?
Miss Henley's juniors, and Mr. Lalonde's juniors.
Anybody in here
Those
vocal
homeroom
height?
students need to report to the theater. And those homeroom teachers, those students will return at around 11:40 to come back to your homeroom to pick up their progress reports. Thank you.
Who's leaving? You leaving? Are you the only one, Kelly? You the only one leaving? I guess that means Jackson would leave, but Madison?
Oh, Madison.
Oh, that's right. I'll just leave this here when it comes back. Okay, we're just doing 1 through 8. All right. So, let's go ahead and finish this up real quick. Oh, goodness.
Mr. Costello?
Yes.
Could you have Edwin Austin come to the office for a minute, please?
Headed that way.
Thank you.
All right, let's finish this up real quick. Let me show you guys the bottom of this note sheet. And I'm going to go through this a little differently. We're not going to do one problem at a time, okay? Let me explain. Some of these questions are really simple. Like, for example, A. What's your initial deposit?
200.
200. Look at B. What's your initial deposit? 1,000, right? On C, what's your initial deposit? 400. And on D, what's your initial deposit? So again, remember, your initial deposit simply means what's your principal amount. You know, I wrote down that you're in the science club. I am going to check that. All right. You are in it, right? It'll show your name there, right? Okay, good. Why? To get out of class. I don't know. Because I had somebody do that in first period. They said that they were in the club, they weren't, and I found out about it. Because they just wanted to wander around. So, alright, so that's an easy question, right? This was also a pretty easy question. It says, how many times was the interest compounded? So look, don't we find that in compound interest right there in the end? So this one's 4 times, right? Or you could also say what? Besides just 4.
Quarterly.
You could say quarterly. Because those are the same words, aren't they? So quarterly. Okay, look at number or letter B. How many times is it compounded? 12 times, right? Or you could say monthly. All right, look at this one. C is kind of a funny question. How many times is it compounded? No. What formula is it? What is that formula called? Continuous compound. So guys, how often is it compounded? Continuously. Continuously. Kind of a trick question there, right? And then the one, for some reason, that tricks people the most, how often is D compounded? Annually, once. Because there's no number up there, it's understood to be a 1. So that's pretty easy, right? Those first 2 questions. Here's the one that's a little more challenging. Let's go back to A. It says, what's the annual interest rate? Annual. Now again, inside here, you remember what we did with the rate? We did 1 plus R divided by N, right? So we derived this number right here by doing 1 plus R over N. Now, let's work backwards. If this is 1 plus R over N, can't we just go ahead and subtract the 1, get it out of the way? So we're dealing with 0.0125. But what else did I do with that 0.0125? How did I get that number? I had divided by the number of times it was compounded. Well, how many times was A compounded? 4 times. So if I work backwards, what do I do with that? Since it had been divided by 4, what do I do to give it back? I'm going to multiply it by 4. So go to your calculator and do 0.0125 times 4. And you'll find your original interest was 0.05. Well, guys, if my original interest was 0.05, what is that as an actual percent? So 5% for A. Okay? Kind of a tricky problem there. So let's do the same thing with B. What's the first thing I need to do? Yes, ma'am.
When I typed in the little equation thingy, I got 0.29.
When you did 0.0125 times 4?
Yes.
Did you raise it to the 4th or did you times 4?
I times 4.
So you did
Let me reset my calculator.
You did 0.0125 times 4.
Yes.
I don't know, you may have, I can't imagine why it would do that.
Okay,
Yeah.
I reset my calculator. I'm looking right now.
Alright.
Okay, it's fine now.
It worked?
Yeah.
Okay. I don't know what was
Yes,
going
I
on.
did.
Alright, so if you look at this one, again, the first thing we're going to do is get rid of the what?
1.
Get rid of that 1 that we added to it. So it's 0.0025, right? But what had gotten it to that point? We divided it by 12 because that's how many times this thing was compounded, right? So we do what to give it back? We multiply by 12. So type in your calculator 0.0025 times 12. Tell me what you get. 0.03. So if 0.03 is my decimal, what's my percent? 3%. Now C is the easiest one because isn't the formula PE to the RT? So isn't my R simply 0.06? That's 6%. And then I think D is the second easiest one because wasn't that just divided by 1? What happens to something if I multiply it by 1?
It's the same thing.
So we're going to be dealing with 0.025. So that's 2.5%. So those are a little harder. You got to kind of work backwards. And you have about 3 of those in tonight's homework assignment. So let me give you that, and we'll call it a week. Okay? So your homework on this page is numbers 1 through 8. 1 through 8. Okay. It's the continuous compound right here. Your brain hurts. It's just been overworked.
What number?
You better need to shut it down for a 3-day weekend.
Body.
Yeah, on that worksheet, it's 1 through 8. That's the first 7 are like almost exactly like the notes, and then number 8's got a little bit more of a challenge to it. See how you do on it. So 1 through 8 is tonight's homework assignment. It's due the day we come back, which is Tuesday. You guys recall, Monday is a day off, President's Day. So you guys, this is due on Tuesday. Tomorrow, if you're curious, there will be a post, and that post will be telling you when the assignments that are getting cut off are due, and they're due Tuesday when we come back. If you haven't turned the assignments that I specified tomorrow on my Google Classroom, if those aren't turned in by Tuesday, they become permanent zeros if you haven't turned them in. Okay? It'll probably be about 4 or 5 assignments. So I would be looking at Google Classroom this weekend, and if you have one of those missing in Synergy, not in Google Classroom. If you've checked it off in Google Classroom, that doesn't always mean it's been turned in. You need to look at Synergy. Everything's been updated into Synergy except what you gave me yesterday, and that will be done, first thing tomorrow morning, if not tonight. It might be done tonight. It's just me. Team must be in yours. I'm in yours. And now you're good to go. The only thing else you might want to consider putting on the formula sheet is if you don't, if you're not comfortable with like monthly, yearly, weekly, but I think you're pretty good to go, right?
I may just want to take a picture of both.
But during the test, you can't have your camera out. You can have your formula sheet out. All right, so 1 through 8 is your homework.
You mean that's all you did?